Frequentist makes it possible to forecast the probability of a future event based on the current frequency. Frequentist works because of the law of large numbers. I'll explain everything you need to know about it in the next 5 minutes. There are two different versions of law of large numbers: the weak law of large numbers and the strong law of large numbers. In 1713, Swiss mathematician Jacob Bernoulli, after 20 years of hard work, proved that the sample average converges in probability towards the expected value. This is known as the weak law of large numbers, or Bernoulli's theorem. It tells us as more trials performed, the frequency will more likely to become closer to the true probability. Be aware that it is only more likely, not a 100% guarantee. Bernoulli's theorem gave us confidence that a random event has a great chance to have a certain probability. About 200 years later, in 1930, Andrew Comograph proved the strong law of large numbers, that the sample average converges almost surely to the expected value. It tells us, as more trials performed, the frequency will become closer to the true probability. Now we can confidently say that there's a certain probability for a random event. The law of large numbers is important because it guarantees stable long-term results for the averages of some random events. How the law of large numbers operates under insurance. Do you think insurance is a very risky business? They only charge a small amount fee, but if something goes wrong, they need to pay much more. Actually, it is not. We can control the risk thanks to the law of large numbers. Imagine there's only one property insurance company, and it charges the same fee to all customers. As we know, older houses tend to have more problems. Then, do you think the new house owner and the old house owner willing to pay the same fee? So, soon enough, there must be another company say, I have two plans, Plan A for new house and Plan B for old house. Of course, Plan A is cheaper than Plan B. The result is, all new house owners move to this company. Follow this track. There must be another company introduce more plans to target their customers. Of course, there are more to consider when dealing with the risk, such as the building structure, material, and location. So, in order to improve their products, the insurance companies try their best to put similar customers to the same group. This is called segregation. Aggregation. How can insurance companies reduce the risk after put similar customers in the same group? Here, the law of large numbers comes to help. As more trials performed, the frequency will become closer to the true probability. If they know the claim probability, they can offer a price that is attractive and also profitable. So, the solution is clear: sign more customers, as more as they can. Another casino example. I'm not going to say the casino has a slightly higher than 50% chance to win the game, so they make money because of the law of large numbers. Imagine that you know a game has a roughly 50% winning chance, and you saw someone play it 4 times and all lose. Do you have the feeling, if keep playing, the next time, rather than 50%, he has a great chance to win? Why? Because the overall probability is 50%, and he lost so many times. You know the law of large numbers? If he keeps losing, how can you say that as more trials performed, the frequency will become closer to the true probability, which is 50%? Well, that's not true. The law of large numbers works, not through compensating for what already happens, but through mean reversion. Let me show you what mean reversion means through an example. If I put a spoon of sugar in a cup of water, you must can taste the sweetness. But How about if I put that spoon of sugar into the sea? Even use the most advanced method, I bet you can't tell the difference. Can you think any other examples of mean reversion? Leave a comment below. 2 takeaways. First, as more trials performed, the frequency will become closer to the true probability. Second, the law of large numbers works not through compensating for what already happens, but through mean reversion. I'm always here at your service. See you in the next one.